What does this mean to you? Okay? What does that mean to you? So take a moment. I won't ask you to do a quick poll on this. It might be a little harder to get an answer. But what does it mean to you? SOHCAHTOA. Okay. Now, hopefully you recognize it as sign is opposite. I'll wait my pen to work here. There we go. Opposite. Did you say over? I don't know how to over. Divide by? Hypotenuse? Okay. So this is sine. We have cosine is? Okay. And we have tangent is? And then again, I just have to ask you, so what do those mean to you? And then to a lot of people, they don't mean a whole lot. So we're going to build this. We're going to build what this means. Okay. Again, we have these phrases in our head, but truly what does it represent? Well, we have to begin with a very basic drawing. Basic drawing is? Well, let's get this. Basic drawing is a triangle, right? Correct? And what kind of a triangle? A right triangle, right. Okay, so there's our right triangle. So if I'm going to look at this angle theta right here, and I say the sine, what I have up here really is not as correct information as I'd like it to be. What should I do with this phrase in order to make it absolutely correct? Sine. Pardon? That's absolutely, yeah. Something's missing there, so I'm going to put in here. Now you say sine theta, like this? Parentheses. Why would you put parentheses around that? Okay. What other mathematical notation do we put parentheses around something in that looks something like that? A function. Absolutely, a function. So we're talking about trig functions. Keep that in mind. So this cosine is not correct. It would have to be cosine theta. And tangent is not really what we'd want to see here. We'd want to see tangent theta. Now, in a function, for every function we have, there are two basic parts. Can you name them? Okay, help me out. What is it? Input and output. Okay, two basic parts of every function. So if we're looking at the input, and we say these are trig functions, so there must be an input somewhere. What's our input? What's our input? That's a good, maybe I should ask you this here. So then everyone's going to respond. So let's do this. I want to know what is the input variable of all trig functions? Give me your best answer. Okay, let's take a look at this. All of you who said theta, the angle, using the theta, you found the symbols, very good. It's like, yeah, but what is theta? And what, it's an angle. What, I'm going to use ABC, angle ABC? No, not the sign of ABC. What is it of the angle that I am using? And so we get down here to the measurements we are given. Well, what do you mean the measurements we're given? The length of the rays? Rays don't have length. Okay, so we can't use that. What are we talking about? The length of the sides? No. Measurement we substitute for theta must be less than or equal to 90. Ooh, you were so close. 90 what? And someone said degrees. You're half there. We're half there. Okay, now, when I say I want the sine of 27, what? Degrees. If I say I want the sine of pi divided by 6, pi divided by 6 what? Radians. Now, when I say pi divided by 6, about how many of those angles are we talking about? Pi divided by 6. About how many of those angles? About how many? Pi divided by, about how many of this angle, of this, pi divided by 6. Pi is how much? 3.13. Divided by 6 is? So about half of this angle. So maybe about 30 some degrees in there. Okay? So if I'm talking about pi divided by 6, then I'm talking about a degree, a measure of radians. If I'm talking about 23, I'm talking about degrees. So let's make this our statement here. For all trig functions, the input variable is the measure of what? For all trig functions, the input variable is the measure of degrees. Pi divided by 6 radians. Those are measures of what? And what does theta represent? Angle. Yeah, the measure of an angle. Okay? For all trig functions, that input is not the symbol for an angle. It's not the letters we use for an angle. It's not the length of that. It is the measure of an angle. Now, we measure those in either degrees or, I'll get this to work here, degrees, there we go, or radians. Now, there is a distinct relationship between the radian measure of the angle and the arc length. So those of you thinking, but I thought it was arc length, you're right. You're right. What's the arc length of a circle? 2 pi. How many of these angles can I fit in here? 2 pi. Okay, so 6.28, 6 1/4. But you need to remember that the input variable is the measure of an angle. Okay, here's your next question. Another quick poll. What is the output variable? There we go, get it correctly. What is the output? Okay. If the input is the measure of an angle, the output can't be the same thing, or won't be the same thing. So what we have then, this says opposite divided by hypotenuse. Opposite what? opposite side, okay, opposite the angle, and this is the hypotenuse, or the length of the side. So on the sine, we have, let's see, this is our hypotenuse for everything. And for the sine, this would be the side opposite. Actually, it's for this angle, it would always be the opposite. And we call this then the adjacent side. So for sine, we're dividing the length of the side opposite the angle with the length of the hypotenuse. For cosine, we're dividing the length of the side adjacent to the angle by the length of the hypotenuse. And for tangent, we're dividing the length of the side opposite with the length of the side adjacent. These are known as ratios. Okay, so it's a ratio between two sides of a right triangle. The output of a trig function is going to be a ratio between two of the three sides of a right triangle. So let's put that in our notes here. The output variable, spell that wrong, variable, is the measure of, oops, I'm going to erase that. I don't want the measure of, we're going to make it, is the ratio between two sides of a right triangle. Now, which two sides? That depends on what? Depends on what? Whether it's sine, cosine, or tangent, right? Yeah. Or cosine, cotangent, cosecant, thank you. I almost lost that one in my head. Okay, so now this is important information, because if we don't know what we've got when we have a trig function, then it's always going to be this elusive numbers and pi floating around like we had at the beginning. Well, let's take a look and see what we have here. The length of one side of a triangle divided by another, correct? Yeah. The ratio of two sides that form angle theta. Now, is it the ratio of two sides that form angle theta? Not necessarily, because it could be the opposite side, and that opposite side is not forming the angle theta. But you get the right idea. The length of triangle legs, does that include the hypotenuse? We don't often call the hypotenuse a triangle leg. Measurement of an angle, this one, absolutely no. This is the input, not the output. If you say it's the trig function, that's too general. We need more specific. Measurement of the proportion of two sides, absolutely correct. The length of the side, meaning one, no, it's the ratio between two sides. The other sides measurements, yeah, but what do you do with those? Add, subtract, multiply, divide. Proportion of the lengths of the sides of the triangle created by the input angle. Absolutely. Measure of the lines, a little too general. Ratio between two sides, make sure it's a right triangle, because we only talk about this with right triangle, generally speaking. We can do others, but generally speaking. Ratio of two sides used to form that angle, no. It could be the opposite side value, no. That's the input. X, what does X represent? Absolutely meaningless, so please don't use that. Ratio of the lengths of two sides of what? Be specific, of a right triangle. Same thing here, measure and length of the unknown side. I don't know what we do that, because we have to be we have to have two sides of the triangle in order to have a ratio. The length of the radius, no clue. That's an honest one. Okay. Number of inputs you can fit into one circle, no. Length of one of the sides, no. This is too, a fraction, I'll take that. It is a fraction, but let's know what the fraction is. Arc length of an angle, that is actually